So today's topic is going to be valence electrons, a topic probably very familiar to you from general chemistry, but you're probably going to learn it on the first day of organic chemistry. So let's talk about the two main things that usually comes up when we talk about valence electrons. So the two main things that come up are number one, valence electrons are used in covalent bonding. So an atom uses its valence electrons in order to bond with other atoms. And number two, the useful thing for us is going to be that valence electrons help us figure out an atom's charge. So it's helpful in the prediction of charges. Okay? Now, before I tell you how to identify valence electrons, let's talk about electrons in general. So let's take this back to 4th grade science, and we're going to draw a nucleus here. So a nucleus has protons, so we're going to say the blue dot is a proton, and has neutrons. So let's say the green dot's a neutron. So together the proton and the neutron make up the nucleus. Now, where are the electrons? Well, the electrons surround the nucleus, okay? Surround the nucleus. We just don't know where they are, okay? Electrons are clouds of density that basically runs around the nucleus. Now, because we don't know where they exactly are, we draw energy levels or energy shells to kind of help us quantify where these electrons might be. So I'm just going to draw 3 energy shells here, okay? So these shells help you figure out, or basically help us identify where electrons might be. Think about it as me saying I live in Texas, okay? You don't know where in Texas, you just know I'm somewhere over there in that part of the United States. Okay, so each energy shell can actually hold a max number of electrons, okay? So I'm going to just tell you that here. So the first energy level can only hold 2 electrons, and the second energy level can only hold 8 electrons, and the third energy level can only hold 18 electrons. Now, you don't have to memorize these values. There's actually a really handy formula you can use in case you ever forget. The number of max electrons in a shell, okay, is 2 parentheses n to the second. So let's take the second shell, for example. So shell number 2, we're going to replace n with 2. So 2 to the 2 is 4 times 2, which gives us 8. Okay? So this is a formula you can use if you ever forget these electron numbers. Now, let's talk about the most famous element in this class, which is going to be our buddy carbon over here. Now, carbon has how many electrons? Well, if you look on the periodic table, carbon is going to have 6 protons. If it has 6 protons, it must have 6 electrons as well. So let's start filling up these electrons in these beautifully drawn shells that I drew over here. So this first shell can hold 2 electrons, okay? So we're going to draw 2 of carbon's electrons in that shell, right? Now, the next shell can hold up to 8 electrons, but we only have 4 left, so I'm just going to draw 4 electrons right there, okay? And that is the atomic model for carbon. Now, well, what are the valence electrons then? How many valence electrons are there? Okay, well, valence electrons, okay, are the electrons that are in the outermost filled shell. Okay, so we have 2 filled shells here. We have the first shell. Okay, so I'm just gonna draw a little, let's say, line to it. We have the first shell right here that has 2 electrons, and we have the second shell over here that has 4 electrons. Now, out of these two, the second shell is the most, I guess, outer, right, or the outermost. So the outermost shell that's filled has 4 electrons, meaning carbon has 4 valence electrons. Okay, carbon has 4 valence electrons. Now you can draw all these models if you want to, but you really don't have to. Okay, there's a secret to knowing how many valence electrons an atom has, and the only ones we care about are going to be in 7 groups. Okay, so this first group right here, the hydrogen, the lithium, the sodium, and so on, all of the atoms in this group are only going to have 1 valence electrons, and all these atoms in the second group here are going to have 2 valence electrons, and all the atoms here, we're going to skip all of these transition metals. We don't care about them for the majority of this class. So everything in group 13 is going to have 3 valence electrons. Everything in group 14 is going to have 4 valence electrons, so carbon has 4, which we just proved over here. Everything in group 15 is going to have 5. Everything in group 16 is going to have 6. Everything in group 17 is going to have 7. Okay? So, for example, if I asked you how many valence electrons does oxygen have? Okay? Oxygen is going to have 6 valence electrons because it's in the period, or it's in the group 16. Okay? Now, let's see why these valence electrons are important, all right? So we talked about that valence electrons are useful in the prediction of charges, okay? Now what we're saying is that when carbon, let's say purple again. So when carbon has 4 valence electrons, so I'm just going to draw a line here. When carbon has 4 valence electrons, it's neutral. It doesn't have a positive charge, and it doesn't have a negative charge. But let's say somehow carbon only has 3 electrons now. Okay, it's missing 1. It's missing 1 electron. So an electron has a negative charge, right? So if you lose 1 electron, what kind of charge will carbon get? Well, carbon will get a positive charge. All right. Well, let's do a couple examples of these to kind of just cement it in. So I'm just going to scroll down here a little bit, and I'm going to draw out some molecules, and we're going to predict the charges of these molecules, or of each atom in the molecule, okay? So let's say we have a nitrogen here, and it's going to be double bonded to an oxygen, and we're going to have a single bond here to an OH, and we're also going to have this. Okay, so, and let me draw lone pairs here as well. All right, cool. So this is the molecule that we have. Whoops. Sorry about that. So I'll give you away the answer. So this is the molecule that we have here, okay? So let's predict the charge of each single atom in this molecule. Now, how many valence electrons does oxygen want in order to be happy? So oxygen, let's scroll back up here. Oxygen wants to have 6 valence electrons, 6. So let's see if we can find 6 valence electrons around every oxygen. So let's start with this one right here. So this oxygen right here, around this oxygen it has 1, 2, 3, 4. And remember, a bond is made up of 2 electrons, so 1 on each side, 5, and 6. This oxygen is happy because it has 6 valence electrons. What about this oxygen? Is this oxygen happy? Let's see. 1, 2, 3, 4, 5, 6. Yeah, that oxygen is also happy. It has 6 valence electrons. Now let's look at this oxygen here. It has 1, 2, 3, 4, 5, 6, and 7. This oxygen has 7 electrons around it and not 6. So if you have 1 extra electron, you're going to have a negative charge. All right? So we dealt with all the oxygens. Now let's deal with this little hydrogen over here. Now hydrogen, because it's in the first group, has only one valence electron. So this hydrogen right here has only one anyway, so the hydrogen is also neutral. Okay, now let's look at this nitrogen. This nitrogen, on the other hand. So the nitrogen, because it's in group 15, has 5 valence electrons. Now let's see if it has 5. So this is the nitrogen. We're gonna have 1 electron around it, and the second one is here, and the third one is here, and the fourth one is here. So the nitrogen only has 4 valence electrons right now, but it wants 5. So if it has 1 less than it usually wants, it's going to have a positive charge. Okay? Now, at first, this is going to be very tedious in order to figure out how many charges something's going to have. But there is a little table that I can make for you to make all this stuff a lot easier. Okay, so let's take it step by step. Let's talk about carbon, for example. Okay, carbon, I'm just write a line here. Carbon is going to be neutral, right, when it has 4 bonds. Okay, 4 bonds. And it will have lone pairs. Lone pairs will have 0 lone pairs. Okay, so a carbon will always be happy when it has 4 bonds like this. Okay, now let's talk about oxygen. So oxygen will be neutral when it has 2 bonds and 2 lone pairs. And we're going to talk about nitrogen now. So nitrogen is neutral when it has 3 bonds and 1 lone pair. And finally, the halogens are neutral when it has 1 bond and 3 lone pairs. Okay, so just to show you a couple examples of that, let's look at carbon. So carbon over here, 1 bond, 2, 3, and 4. Let's look at the valence electrons. There's the 1, 2, 3, and 4. Now let's look at oxygen, okay? So let's say we drew a C double bonded to an O, and then we're going to draw just 2 H's off of here, and the oxygen has 2 lone pairs. So it's very Christmassy here. So we're going to have 1, 2, 3, 4, 5, 6. So look at that. 2 bonds, and 2 lone pairs. Okay? Now what about, let's look at nitrogen. So nitrogen, let's say 3 bonds here, and we're just going to draw an H, another H, and another H. And here are the electrons. 1, 2, 3, 4, and 5. So 5 electrons, meaning nitrogen has 3 bonds, 1 lone pair, it's neutral. Now finally, let's look at halogens. Right, halogens. I'm just going to scroll a little more down here. Oops. So, let's go to the left. So we're going to have halogens right here. So let's see how many valence electrons it has. 1, 2, 3, 4, 5, and 6, and 7. 7 valence electrons in total. Now because it has 7 valence electrons, it's neutral because halogens want 7 valence electrons, and halogen has 1 bond and 3 lone pairs. Okay, I hope this helped you guys a lot. Stay tuned for the next video.